Welcome back, listeners, to another exciting episode of JVM Internals Crashcasts. I'm your host, Sheila, and with me as always is our JVM expert, Victor. Today we're wrapping up our Beyond Expert season with a fascinating topic, JVM in the age of microservices and cloud-native applications. Victor, are you ready to dive in?
Absolutely, Sheila. I'm excited to explore this topic with our listeners. It's a great way to conclude our season and look towards the future of JVM technology.
Before we begin, listeners, let's quickly recap where we are. We're in the final chapter of our Beyond Expert season, focusing on the future of the JVM. We've covered Project Loom, Project Valhalla, and Project Amber in previous episodes. Today's topic ties everything together as we explore how the JVM is adapting to modern software architectures.
That's right, Sheila. And for our listeners to get the most out of this episode, they should be familiar with basic JVM concepts, have an understanding of distributed systems, and know a bit about cloud computing. Don't worry if you're not an expert in these areas. We'll explain key concepts as we go along.
Perfect, Victor. Now, let's kick things off with a quiz for our listeners. Here's the question. In a microservices architecture using JVM-based services, how does the total memory footprint compare to a monolithic application with equivalent functionality? A. It's always smaller. B. It's always larger. C. It depends on the implementation and configuration. D. It's exactly the same. Think about it, listeners, and we'll reveal the answer at the end of the episode.
That's an intriguing question, Sheila. It really makes you think about the trade-offs between different architectural styles and how they impact resource usage. I'm curious to see what our listeners will guess. Without giving away the answer, I can say that this question touches on some key considerations when designing microservices with the JVM.
Absolutely, Victor. Now let's start by defining some key terms for our listeners. Can you explain what we mean by microservices and cloud-native applications?
Certainly, Sheila. Microservices is an architectural style where an application is built as a collection of small, independent services that communicate over well-defined APIs. Each service is focused on doing one thing well and can be developed, deployed, and scaled independently. Cloud-native applications, on the other hand, are designed to fully leverage cloud computing models. They're built to be scalable, resilient, and manageable in dynamic environments like public, private, or hybrid clouds.
Thanks for that clear explanation, Victor. So, how does the JVM fit into this picture? It's been around for decades. Is it still relevant in this new world of microservices and cloud-native apps?
That's a great question, Sheila. The JVM is indeed still very relevant, but its role has evolved. In the world of microservices and cloud-native applications, the JVM brings several advantages. 1. Maturity and stability. The JVM is battle-tested and has a rich ecosystem of libraries and frameworks. 2. Performance. Modern JVMs offer excellent performance, crucial for resource-efficient microservices. 3. Polyglot support. The JVM supports multiple languages, allowing teams to choose the best tool for each microservice. 4. Strong tooling, profiling, debugging, and monitoring tools for the JVM are well developed, which is essential in distributed systems.
I see. So it sounds like the JVM's strengths are still valuable in this new paradigm. But surely there must be some challenges too.
Absolutely, Sheila. The shift to microservices and cloud-native architectures has presented some challenges for the JVM. 1. Startup time. Traditionally, JVMs had longer startup times, which can be problematic in dynamic scaling scenarios. 2. Memory usage. Each JVM instance has some overhead, which can add up when running many microservices. 3. Resource efficiency. In a containerized environment, efficiently using allocated resources becomes crucial. However, the Java community has been actively working on addressing these challenges. Projects like OpenJ9, GraalVM, and various JVM tuning options have made significant progress in these areas.
That's fascinating, Victor. It reminds me of how cities evolve over time. Just as old cities adapt to modern needs with new infrastructure and technology, the JVM is adapting to new software architectures. Can you give us an example of how these adaptations look in practice?
That's a great analogy, Sheila. Let's take the example of Twitter. They famously moved from a Ruby on Rails monolith to a microservices architecture, with many services written in Scala running on the JVM. They developed tools like Finagle, a protocol-agnostic RPC system, to help their JVM-based microservices communicate efficiently. Another example is Netflix, which runs a large portion of its microservices on the JVM. They've contributed several tools to the open-source community, like Hystrix for fault tolerance and Ribbon for load balancing, all designed to work well with JVM-based microservices.
Those are interesting real-world examples, Victor. Now, I've heard some developers say that the JVM is too heavy for microservices. Is this a common misconception?
Yes, Sheila, that is indeed a common misconception. While it's true that a traditional JVM has more overhead than, say, a Go binary, modern JVMs and tools have made significant strides in reducing this overhead. For instance, the class data sharing feature can reduce startup times and memory usage. GraalVM's native image capability can compile Java applications to native executables, dramatically reducing startup time and memory usage. Moreover, the benefits of the JVM in terms of runtime performance, mature garbage collection, and extensive tooling often outweigh the initial overhead, especially for long-running services.
That makes sense, Victor. So, what do you see as the future trends for the JVM in this microservices and cloud-native world?
Great question, Sheila. I see several exciting trends. 1. Continued focus on startup time and memory efficiency, crucial for serverless and edge computing scenarios. 2. Better integration with container orchestration platforms like Kubernetes. 3. More advanced AOT, ahead-of-time, compilation techniques to improve startup performance. 4. Enhanced support for reactive programming models, which align well with microservices architectures. 5. Improved tooling for observability and debugging in distributed systems. Projects like Loom, with its virtual threads, will make it easier to write highly concurrent applications, which is crucial in microservices architectures.
Wow, it sounds like there's a lot to look forward to. Before we wrap up, let's reveal the answer to our quiz. Victor, would you like to do the honors?
Certainly, Sheila. The correct answer to our quiz is C. It depends on the implementation and configuration. In a microservices architecture, you typically have multiple JVM instances, each with some overhead. However, these can often be more finely tuned than a monolith. Additionally, the ability to scale services independently can lead to more efficient resource usage overall. So the total memory footprint really depends on how the microservices are implemented and configured.
Thank you, Victor. To summarize today's episode, 1. The JVM remains relevant and valuable in the age of microservices and cloud-native applications. 2. While there are challenges like startup time and memory usage, the Java community is actively addressing these. 3. Real-world companies like Twitter and Netflix successfully use JVM-based microservices at scale. 4. The future of JVM in this space looks bright, with ongoing improvements in efficiency, tooling and support for modern programming models. This concludes our Beyond Expert season. We've covered a wide range of advanced topics, from JVM security to alternative implementations, and finally, the future of the JVM. We hope you've enjoyed this journey into the depths of JVM technology.
It's been a fantastic season, Sheila. I'm continually amazed by how the JVM evolves to meet new challenges while maintaining its core strengths.
Absolutely, Victor. And to our listeners, thank you for joining us on this deep dive into JVM internals. If you've enjoyed the series, please subscribe and leave us a rating. Your support helps us continue creating in-depth technical content. Stay tuned for our next season, where we'll be exploring more cutting-edge topics in the world of JVM technology.